Hello, welcome back. In this video, we will look at a case study in section 16.5 on finding Fibonacci numbers. Please recall that we introduced a recursive solution for Fibonacci numbers. This is the Fibonacci numbers here. It's a sequence of numbers starting from 0 and 1, and all the subsequent numbers is the previous two numbers add together. So that's the Fibonacci number, and we use a recursive solution. This is the recursive solution to find the Fibonacci number at the given index. So this is the best case. If the index is 0, it's return 0. If the index is 1, return 1. Else, we're going to return the previous two Fibonacci numbers add together. So this is recursion. Now, the time complexity of this, if you add together, you're going to see that it's order of 2's n. So this is the exponential time. It's impractical. Now we're going to introduce a new solution, and this will lead to order of n times linear time. So what we're going to do is to have this three variables, f0, f1, and f2. So initially, so these are the values. So f0 is for the first, and f1 is for the second value here, and f2 is thus the third. So f2 is f0 plus f1. So now we're going to get in this at index 3. So what we need to do is to see we're going to have these two numbers add together, and we're going to get a new one. So what do we need to do? Just shift. We're going to shift to this the f1, assign this to f0, and f2 to f1. And then we're going to add this two together. We get a new f2. So that's how we're going to do for the next one. The same thing. We're going to do a shift. So f1 is assigned to f0, f2 is assigned to f1, and then we're going to get the f1 plus f2 for the new f2. So again, let's see, we'll see it one more time. All right. So it's constant time to get the next one. If you continue, you have the sizes n, and that's order of n time. And we write the code right here, and you can see this is order of n time for this for loop. Now this algorithm strategy, design strategy, is known as dynamic programming. Dynamic programming is the process of solving subproblems and then combining the solutions of the subproblems to obtain an overall solution. This naturally leads to a recursive solution. However, it would be inefficient to use recursion because the subproblems overlap. So when we use the recursion, we're going to see that the overlap is right here. So when you compute fib index -1, you have to invoke fib index -2 again. So this is a lot of overlap there. Now, so the key idea behind dynamic programming is to solve each subproblem only once and store the results for subproblems for later use to avoid redundant computing. So that's what we do here. And we only need to store it just the previous two. So when we compute the next one, we're going to assign F0, F1 to F0, F2 to F1, and then we're going to get all this, a new number from the summation of the previous two numbers.
Assign F1 to F0, F2 to F1, and F0 plus F1 to F2.
So that's it. All right, that is all for this section on the case study of finding Fibonacci numbers. See you on the next video.